Nearly 200 earthquakes hit Yellowstone National Park. It's a sign of what's going to happen in the United States. People fear that the supervolcano might erupt any day. What led to the current condition of Yellowstone National Park? Should America be worried about what's coming? We need to have a deep understanding of Yellowstone National Park. Only then can we find out the core reasons for the repeated earthquakes. Many people have listed the park as a place to visit when they visit America. The beauty of the place cannot be explained in words, but it's breathtaking. Yellowstone National Park is like a wonderland every Alice dreams about. Every visitor would have a big smile on their face after taking a tour of the park. As we explore the beautiful part, we'll reach the Yellowstone caldera. More than 10,000 hydrothermal features are in the park. The geothermal activity of the park is what makes it stand out. There are hot springs that are heated naturally due to the heat. The temperature of the water varies from time to time. Sometimes it boils, whereas on other days it's just warm enough. What you see right here is brightly colored water. Well, the water's not colored. The mineral deposits make it look so vibrant. Some gases get released from time to time. It's highly poisonous and it's better not to go near it. Keep this in mind when you visit Yellowstone National Park with your loved ones. The upper and lower water along with colorful rocks is what makes the Grand Canyon special. This place is a shelter for wildlife animals. Different types of animals live there and the place provides a refuge for them. Due to varying climatic conditions, many animals suffer from not having a stable environment. This is when Yellowstone National Park comes into play. There is no other place that offers scenic beauty and a safe living environment for wildlife. This park inspires us to preserve the natural areas. It would be a good step for the benefit of the wildlife and maintaining the ecosystem. You can experience all 4 seasons here, from a tropical experience to a winter climate. You'll get to have a lovely time here. There are many historical sites here as well. To give an example, we have the Old Faithful Inn. It was built in 1904. There's something extremely dangerous sleeping in Yellowstone National Park though. It's the Yellowstone supervolcano. Is it going to erupt anytime soon? The first eruption is believed to have occurred around 2.1 million years ago and was one of the largest in Earth's history. The Huckleberry Ridge eruption, a result of this explosion, blanketed an area of more than 6,000 square miles in ash and lava. The second known eruption, which occurred about 1.3 million years ago, included a significant volcano explosion as well. This eruption, also known as the Mesa Falls eruption, produced more than 280 cubic miles of volcanic material, which led to the formation of Henry's Fort caldera. The most recent eruption, the Lava Creek explosion, happened roughly 640,000 years ago. This eruption produced more than 240 cubic miles of volcanic material, which covered an area larger than 5,000 square miles and created the Yellowstone caldera, which is now home to the Yellowstone supervolcano. Since the most recent big eruption, there have been numerous lesser eruptions as well as other forms of volcanic activity, including hydrothermal activity, earthquakes, and gas emissions. To predict the possibility of future volcanic activity and to better understand the behavior of the volcano, the Yellowstone supervolcano is continuously monitored. Remember that even though the Yellowstone supervolcano is active, there is currently no evidence to suggest that an eruption is imminent. The possibility of a future eruption, however, emphasizes the importance of continued observation and research to better understand and anticipate volcanic activity. The Yellowstone caldera's most recent eruption, the Lava Creek explosion, occurred about 640,000 years ago, one of the most powerful volcanic eruptions in Earth's history. This incident has a tremendous impact on the ecology and climate. 3 phases of the catastrophic Lava Creek eruption occurred over around 700,000 years. The defining characteristic of the first stage was the development of a substantial magma reservoir beneath the Yellowstone caldera. The magma chamber eventually underwent an eruption as a result of the expansion and rising pressure. Everyone on Earth was affected by the Lava Creek explosion. Massive amounts of ash and volcanic debris spewed into the sky resulted in large-scale climate change, including cooling of the Earth's surface and changes to weather patterns. The eruption not only destroyed existing ecosystems and produced new lakes and rivers, but it also had a significant effect on the local ecology. The global effects of the eruption on the environment and climate were significant. Even if there are now no signs that the Yellowstone supervolcano is about to erupt, it is nevertheless necessary to keep track of it and conduct research to better understand its behavior and estimate the risk of future volcanic activity. What was the plan of the geologists? One of the indicators used by geologists to monitor the activity of the Yellowstone supervolcano is gas emissions. The gas that the Yellowstone volcano emits most frequently is water vapor, which is emitted by geological features like geysers and hot springs that are found throughout the park. But the volcano also spews out helium, carbon dioxide, and sulfur dioxide in addition to these compounds. Carbon dioxide is regularly emitted by volcanoes as a result of magma rising to the surface. The carbon dioxide emissions from Yellowstone's volcano are more directly related to the park's geothermal activity than they are to any future volcanic eruption. Sulfur dioxide, a gas that the volcano is generating, is particularly concerning because it denotes an increase in volcanic activity. An increase in sulfur dioxide emissions could indicate that magma is moving closer to the surface and is likely to erupt. Helium is another gas that the Yellowstone volcano generates, and scientists use it as a tracer gas to track the subsurface flow of magma. Helium is created through the radioactive disintegration of uranium and thorium, which are abundant in the rocks beneath the Yellowstone caldera. The magma comes to the surface carrying helium, which may be detected by scientists to determine the exact location of the magma chamber. Helium in the Yellowstone caldera is mostly sourced from the mantle and radiogenic sources. Helium from the mantle is created through the radioactive decay of uranium and thorium in the Earth's mantle. The volcanic process that brings these gases to the surface also contains helium, which is a crucial component. Yellowstone has been found to contain mantle helium, which proves that the volcano is getting its energy from a deep mantle source. On the other hand, radioactive substances that are present in the rocks beneath the Yellowstone caldera, such as uranium and thorium, produce radiogenic helium when they decay. The helium inside the rocks is released into the atmosphere when they become heated due to erosion or volcanic eruptions. Radiogenic helium is often found in older rocks, therefore the finding of this gas in Yellowstone shows that the volcano is obtaining helium from a long-standing source. Helium-3 and helium-4, two helium isotopes discovered in the Yellowstone volcano, are essential for understanding the geological processes occurring underneath the surface of the Earth. When radioactive elements like uranium and thorium decay, helium-4, which is the most common isotope of helium, is produced. It is also produced by the fusion of hydrogen atoms in the Sun and other stars. Helium-3, a far more infrequent isotope of helium, is produced by the burning of hydrogen atoms in the interstellar medium. Additionally, the planet's surface and the atmosphere also contain trace amounts of it. Knowledge of helium-3 and helium-4 is required to comprehend the geological processes occurring under the summit of the Yellowstone volcano. By analyzing the ratio of these isotopes and volcanic gases and sediments, scientists can discover a lot about the past and present activity of a volcano, and use this information to learn more about volcanic processes in general. A scientific institution called the Yellowstone Volcano Observatory keeps an eye on the Yellowstone caldera. The United States Geological Survey, the University of Utah, and the National Park Service are working together on it. Its primary objectives are to identify the first eruption warning signs and to educate the public about safety measures. The Yellowstone Volcano Observatory was established in 2001 as a result of worries that a catastrophic eruption could occur in Yellowstone National Park. The observatory's job is to monitor the Yellowstone caldera for signs of an increase in volcanic activity and to warn of any potential eruptions in advance. Seismometers, GPS receivers, and satellite photos are just a few of the monitoring tools it employs. Seismometers pick up and keep track of the seismic waves that earthquakes and volcanic eruptions produce. The Yellowstone Volcano Observatory sees a network of seismometers spread throughout the Yellowstone caldera that continuously monitor the area's seismic activity. The information collected from these seismometers is used to track modifications in the volcano's behavior, such as the occurrence of earthquake swarms and the flow of magma underneath. The monitoring techniques used by the Yellowstone Volcano Observatory are analyzed by a team of scientists who look for patterns and trends that might indicate a higher risk of volcanic activity. In exchange regarding the Yellowstone caldera and other volcanic risks, the scientists work closely with researchers from various institutions and organizations. Do you anticipate another volcanic eruption near Yellowstone? What would occur if such a terrible thing happened? Let us know in the comments.